If you fly in a straight line at a speed of 1 light-year per second, where will you eventually go? This sounds like a sci-fi movie. It contains the profound reflections of human beings about the universe. Today, you will travel at a speed of 1 light-year per second. Embark on this magnificent expedition through time and space, from the familiar solar system, through the nebula galaxy, and finally beyond the known universe. This journey allows you to appreciate the vastness of the universe and the insignificance of human beings. Experience an unprecedented visual feast and a philosophical reflection. Now you are about to say goodbye to this blue planet that harbors life. In 30 seconds, you will be in a deep sea state. The countdown begins. 3029. 1 launch. Your speed soars to 1 light-year per second, equivalent to crossing an astonishing 9 trillion kilometers every second, about 365 times the speed of light. You can no longer see the other planets in our solar system. Everything becomes blurry and illusory, like a tunnel of light and shadow. In just 1 second, you've flown out of the solar system. When you look back, you'll see the solar system as just a speck of dust in the vast universe. At this moment, you are free from gravitational forces. Farewell to the sun. A true interstellar journey begins. When you turn your head in just 4 seconds, you arrive at the closest place to Earth, Proxima Centauri. Proxima Centauri is a red dwarf star. It has only 1/8 the mass of the Sun. This is a triple star system composed of Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Alpha Centauri A is the most similar star to the Sun. However, scientists have been observing the area around Proxima Centauri and discovered a planet called Proxima Centauri B. It is located within the habitable zone. This means that liquid water may exist on this planet, opening up the possibility for life to form. In the novel The Three-Body Problem, the Trisolaran civilization inhabits the Centauri system. Although we cannot be certain whether life exists on Proxima Centauri B, it is undoubtedly an important candidate in the search for extraterrestrial life. After a brief stop, you do not find the Trisolarans, so you shift your focus to more distant celestial bodies. After flying for 8 seconds, you arrive at Sirius, the brightest star in the night sky. This star belongs to the constellation Canis Major and is located about 8.6 light-years from Earth. It is a binary star system composed of a dominant star, Sirius A, and a white dwarf star, Sirius B. Sirius A is a bluish-white main sequence star, 25 times brighter than the Sun, shining with intense light. Sirius B, on the other hand, has a mass similar to that of the Sun, but is a very small white dwarf. Due to its extreme density and very high surface temperature, it presents a unique blue color. A closer look at Sirius allows you to feel the tremendous energy of the star and the magnificent view of the universe. Binary star systems orbit each other, reflect one another, and compose romantic poems of the universe. After 10 minutes of travel, you arrive at the potentially habitable planet Kepler-22b. This is an exoplanet in the constellation Cygnus, located about 600 light-years from Earth. It orbits a star similar to the Sun and is located within the star's habitable zone. Therefore, it is considered a potentially suitable planet for human survival. The discovery of Kepler-22b sparked public interest and endless imagination about the search for extraterrestrial life. If this planet is truly suitable for human life, then it means Earth is not alone in harboring life. 2 hours later, you reach the famous Pillars of Creation. These are located in the Eagle Nebula within the constellation Serpens. It is one of the classic images captured by the Hubble Space Telescope. This nebula of gas and dust forms a pillar-like shape, glowing against the dark backdrop of space, like a sculpture in the universe, beautiful and majestic. The Pillars of Creation are a stellar nursery, where stars are born. The gas and dust within the nebula, under gravitational forces, continuously condense, eventually forming new stars. Once these stars are born, they emit intense light and radiation, gradually illuminating the surrounding nebula and creating the magnificent scene you see. This region reveals not only the grandeur of the universe but also symbolizes the origin and evolution of life. After 5 hours of flight, you arrive at the largest known star, Stephenson 2-18. Located in the constellation Scutum, it is about 19,000 light-years from Earth. The radius of this star is 2,158 times that of the Sun. If it were placed in the position of the Sun, its surface would extend beyond the orbit of Saturn. Stephenson 2-18 is a red supergiant star. The nuclear reactions within it are nearing their end. A supernova explosion could happen at any moment. It is large enough to contain 10 billion suns, or 130 million billion Earths. Standing before Stephenson 2-18, humans feel insignificant, and the greatness of the universe becomes undeniable. After one full day of flight, you exit the Milky Way galaxy. The nebulae and dust within it start to fade from view. As your vision expands, you witness the 100,000 light-years span of the galaxy, reflecting before your eyes. It resembles a giant vortex. You can even see the dense central region of the Milky Way, glowing brightly due to the vast number of stars gathered there. At this point, you finally gain a comprehensive understanding of our home galaxy. After 29 days of flight, you arrive at the nearest galaxy to the Milky Way, the Andromeda Galaxy. Andromeda is the largest galaxy in the local group, with a diameter of approximately 220,000 light-years, making it larger than the Milky Way. In your future journey, you will witness the collision of these two galaxies, an extraordinary and magnificent cosmic event. It will be one of the most stunning sights in the universe. After 115 days of travel, you reach the outskirts of the local group, which contains around 50 galaxies. The local group is a gravitationally bound cluster of galaxies. They interact with each other and move together through space. At the edge of the local group, you can observe many other galaxies, varying in size and shape. The structure of these galaxy clusters also shows diversity. Some are densely packed, while others are more dispersed. These galaxy clusters are fundamental building blocks of the universe. After 3 years of flight, you have moved far beyond the local group and discover that you are inside a much larger structure, the Virgo supercluster. The Virgo supercluster contains more than 30,000 galaxies and is made up of numerous galaxy clusters and groups. It is a massive gravitationally bound structure. After 16 years of continuous travel, you finally exit the feather-like Laniakea supercluster. With a diameter exceeding 500 million light-years, it contains around 100,000 galaxies. It is one of the largest known structures in the universe. In the Laniakea supercluster, galaxies follow filamentary structures, like the nerves of the universe, connecting galaxy clusters. The Milky Way, in this context, is just a tiny dot among these immense cosmic structures. After more than 100 years of travel, you finally arrive at the largest black hole ever observed, TON 618. TON 618 is located in the constellation Canes Venatici. It is a supermassive black hole with a mass approximately 66 billion times that of the Sun. TON 618 engulfs the surrounding material, releasing immense energy and forming a bright accretion disk. The existence of such a massive black hole reveals the extreme conditions of matter in the universe. It also demonstrates the powerful gravitational forces at play and offers a glimpse into the depths and mysteries of space-time. After contemplating your journey of over 1,000 years, you finally reach the edge of the known universe, the boundary of the observable universe. It lies about 46.5 billion light-years from Earth. However, this is not a fixed boundary, but rather one that continues to expand with the universe. What you can observe from this point originates from the cosmic microwave background, emitted shortly after the Big Bang. The light has traveled for approximately 13.8 billion years, but due to the universe's expansion, the distance it has covered has stretched to 46.5 billion light-years. Standing on the edge of the observable universe, you feel the overwhelming scale of existence. Time becomes almost infinite here, and space expands without limit. If you continue onward, you will transcend the universe. This is not a physical wall. but the limit of light's reach. If you travel only at the speed of light, crossing this threshold means you can never look back. Fortunately, you're traveling at 1 light year per second, so a return should be possible. Yet what lies beyond may completely challenge your understanding of reality. What you see next exists only in current scientific theory and speculation. The first vision you may encounter is the geometry of the universe. It appears to be nearly flat. This means that the area you observe and the space beyond it follow the same physical laws. Galaxy clusters and superclusters exist beyond the observable universe, but due to their vast distance, we cannot see them directly. Because of the universe's expansion, the light emitted by these distant objects will never reach us. Therefore, we cannot know of their existence through direct observation. The second vision you might witness is the multiverse. According to this theory, our universe is just one bubble in an infinite multiverse. As the universe expands, new bubble universes may form due to quantum fluctuations. Each of these bubble universes might have different physical constants and laws of physics. Perhaps, in some bubble universes, the gravitational force is very different from ours. In others, the speed of light might be infinite. Unfortunately, we have no access to these other universes. They remain forever out of reach, beyond any experiment or observation. The third vision you may encounter is the dark side of the universe. Even within the observable universe, a vast amount of matter cannot be seen directly. Dark matter and dark energy. These invisible substances constitute most of the universe's mass and energy. Beyond the observable boundary, their distribution might differ from what we perceive. For example, the density of dark energy could vary over time, or new forms of matter and forces may exist that we have not yet discovered. Although you cannot directly observe the light beyond the observable universe, gravitational forces still operate. They influence the future of our cosmos in profound ways. And inevitably, such a journey leads you to reflect on a few fundamental questions. Is the universe finite or infinite? What is the shape of the universe? What is the origin of the universe? This voyage through the cosmos is just a small part of our understanding. Beyond what we can observe, perhaps there is endless space. Even though we may never fully comprehend the universe, our pursuit of discovery never ends. Through continued exploration, we can deepen our awareness and appreciation of the universe's wonders and gain a more profound understanding of the value and significance of humanity. May this journey bring you spiritual clarity and a beautiful dream. Good night.